Okay, so we're going to take a look at a multi-part problem, but it's an interesting problem, and it may seem very confusing at first, so I wanted to go ahead and make a video on it so we could fill in some of the information on it and what I want you to see from this. Now, here's what we're going to do. In this problem, it's got a couple of different parts, and they say that a 53 kilogram skier is at the top of the slope, as in the figure, so they have a picture of it. It looks a lot like this. And we've got a skier up here. Let's see, their mass is 53 kilograms, and they're at two different points. Let's see, the initial point A, so we're going to call this A, and then the final point B, which is down here, B, they give us the following. The skier is 17.3 meters above the final point B. So what they're saying is, this value is 17.3 meters above. Now, one of the things that I'm going to add in here so that it makes a little more sense is, we're going to say that this goes down a little bit more outside of what we see. And I'm going to say that the ground is over here, y equals 0 meters, and that this is a height of 10 meters above. Okay, now that's not included in the problem, and you may be wondering why. I think whoever wrote this had it kind of a different setup. That's okay. There's a distinct reason why that's not there in the problem, and that's part of why I've chosen this problem for you to take a look at. So here's what we're going to do. The first question is they want to find the difference in potential energy due to gravity at the 2 points. In other words, what they want is potential energy due to gravity at B minus the potential energy due to gravity at point A. And that's what they're looking for. Okay, so here's what we're going to do. With this information, let's go through, and part one is to find the difference in the potential energy between these 2 points. So here we go. I'm going to find, well, our potential energy for gravity at point A, or 0 as we usually use, but A works perfectly fine. It's going to be mgya, which is going to be our mass, which is 53 kilograms, times g, 9.81 meters per second squared. I believe they have 9.81. Yep, 9.81. Times ya, our y coordinate here at point A. Well, if y equals 0 is way down here, we're up 10, and then another 17.3, so we're at a height of 27.3 meters above ground level. Okay, so I'm going to multiply all of that out, and I'm going to find that my potential energy due to gravity, let's see, 53 times 9.81 times 27.3 is equal to, we have a staggering initial potential energy due to gravity of 14,194 joules. Great. I'm going to do this quickly, but let's find the potential energy due to gravity at point B. I presume you all can do that. We're going to do mass of the skier. That doesn't change. The acceleration due to gravity, that doesn't change. And YB, which is at a height of 10 meters. YB equals positive 10. Okay, so I'm going to do that. I'm going to do 10 times 9.81 times 53 in a weird reverse order. And I find that I have 5,199.3 joules. Let's call it 5,199. You could even call it 5,200 joules, which would be perfectly fine as well. We're trying to find the difference in potential energy. Let's see. I think they want just how much energy we have lost. So I instinctively wrote it as delta PE, and I will remind you that delta is always final minus initial. In this case, they're looking for just the change, so we will do a positive. That's fine. But technically, we've got delta PE is going to be final 5,199 joules minus initial, which is 14,194 joules. My delta, 5,199 minus 14,194, I get the following. Delta, final minus initial, is equal to negative 8,995 joules. Now, they don't actually want delta, they just want the change. So what I'm going to put in is positive 8,995 joules. Let me check our answer. And we find that the correct answer that they have listed is 8,994.79. It's 8,995. In fact, it would be just fine taking probably 9,000 on the nose, rounding it to 3 significant figures. But this is perfectly fine. We'll keep 4 for now. This is what we're looking for. We're looking for the change in potential energy. Technically, if I were writing this, I would probably ask for delta PE, and we would have a negative letting us know that we lost gravitational potential energy. Now, a quick side note question, where do you think that energy went? Food for thought for another time. Part 2 is not necessarily what you might think it would be. In part 2, we instruct the following, that it's the same scenario, except this time they say that instead of paying attention to the ground way down here, we're going to say that YB is equal to 0 meters. We're going to say that this is our new ground level. That seems a little strange, but okay. They say, find the difference in potential energy if the 0 level, oh, I'm sorry, I read that wrong. If the 0 level is up here at A. They said that YA is equal to 0 meters. Now that's especially weird. Why would we put our 0 way up there? But that's actually the point that I want to get across on this, where we're actually dealing with the several different ways that we can set up y equals 0. Well, if this is y equals 0, then down here YB is equal to not 17.3 meters, but negative 17.3, because we are now beneath that. We used to have something that I fictitiously made up down here because I misread the question, but here we are, and it's still perfectly fine. We're setting our y equals 0 up here, because this will still emphasize what I want to show you. All right, well, everything's pretty much the same, except now we want our potential energy due to gravity at A. Well, that's going to be nothing more than our mass, 53 kilograms, times 9.81 meters per second squared, times our new y-coordinate is 0 meters. All right, oops, potential energy due to gravity at B is 53 kilograms times 9.81. I'm going to leave the units off to get some space. Times our new y-coordinate, which is negative 17.3 meters. In this case, I find that my potential energy of gravity at A is equal to 0 joules, I almost wrote meters, and at B is equal to negative, let's multiply this out and see what we get. 53 times 9.81 times negative 17.3 gives me, look at that, negative 8,995 joules, at least to 4 significant figures. If I want to find delta PE, which is my preferred, but not what was actually set up for this problem, we would have the final negative 8,995 joules minus the initial, minus 0 joules, and we would find that once again our delta potential energy for gravity still comes up to negative 8,995. Why is it negative? Once again, we lost gravitational potential energy, and you can see that it didn't matter where we set y equals 0, we still got the exact same change in energy. All right, the value you would put in, once again, they're not looking for delta, they just want the positive value, so 8,995. The last part of this question is, they tell us, okay, what if we set y equals 0 right here in the middle? Well, that means that YA is going to be equal to 17.3 divided by 2. That's going to be positive 8.65 meters. And down here at YB is equal to negative 8.65 meters, so that we still have 17.3 meters from here to here. Y equals 0 here, so above is positive, below is negative. Now, we could go through and we would find the following, that our potential energy due to gravity at point A is going to be equal to, let's see, 53 times 9.81 times positive 8.65. We're going to get positive 4497 joules, technically 0.4. And we're going to find that our potential energy due to gravity at point B is, well, plugging that in with negative 8.65, if I've done this correctly, will be negative 4497 joules. All right, finally, let's double check our outcome. Our change in potential energy due to gravity, specifically delta, is going to be final minus initial, which our final is still negative 4497, minus our initial, minus a positive 4497 joules. We can find that our delta is, let's see, ignoring that I rounded a little bit there, but we've got 4497 times 2. We end up with negative 8,994. That would be 95, except I dropped off the 0.4. It'd be 0.8 over here, which would round up to the 8,995. In fact, I told you before that we'd probably just round this to 9,000. In short, we see that it doesn't actually matter where we set our y equals 0. We keep coming up with the same. And strangely enough, you can have negative gravitational potential energy. As long as you are consistent, you will continue to get the correct answers no matter where you set your y equals 0.